So I have got my IntelliJ open, and let's write some unit test code to understand filter interface in details. So alt insert package chapter 21. I'll just mark it as say filters to make it simple. Control C, and I will enter it. So we got a filters package created here. Similarly, we'll create a similar package in test. So alt insert package, control V. Okay. So we got the package created now. Now let's create a very simple Java Pojo class, which I will copy from the previous to just save some time. So I'll copy a very simple from chapter 4, marker data with versioning. So control C and control V. And I will just mark it as with filters. Okay. Now let me make some changes here. So I will simply go here and randomly change this serializer. That's it. So it generates this one. And the private fields are looking good, but still let me make the changes. Just remove it because it's very naive and easy. I'll remove everything from here and then generate. So alt insert, getter and setter, control A, okay. And similarly, I will generate a toString method as well. So alt insert, toString, okay. Control alt L to reformat the code and remove any unused interfaces or classes that we are importing. Okay, so our Java Pojo class is ready. We are making it very simple, just creating string, private members field as string, and primitives as long, double, and boolean. So let me also create the test class for it. So I'll control C, and I will go to the test package, alt insert Java class with filters test. Okay. Again, to save some time, I will copy the unit test from some previous chapter. So I will again go to chapter 4, market data with versioning test, because it's very simple. So I just copy this from here, copy both the test cases. So control C. Yep, okay, and come here and control V. Okay. So let's make some small changes here as required for this chapter. So market data with filters test. First of all, let me copy this and put it as our serialized file name. Setup is looking good. Now let's go to test serialize. So I'll change the name as display name as with filters, and let's change the name of this. Okay, so the Java Pojo that we are creating should be for this chapter. So with filters, and then we create the state of the object. We are creating for Apple again. Everything is good. So test serialize method is looking good. Now, as we discussed before, that for deserialization process, we will implement this two ways to filter our deserialization, which is using the custom filters by implementing check input from object input filter interface. And the second, we will check for pattern-based filters. And let me do it for serial class first, that the class of an object being deserialized, it's exactly same as market data with filters that we are checking here. So let me change the first test deserialize method. So I will change this as say shift F6 and test deserialize based on serial class, and I will use the very simple way of allowed. So what it means is that we'll call this serial class method, and we'll check that whether the class which is being deserialized, it is same as market data with filters. If there's anything else, we will reject it. So this is how we are going to do it, which we'll implement just now. So also I will change the name of the display. So it should be with Java Pojo. So I will change it to say based on serial class. And for this test case, I will mark it as allowed. Okay, so let me also make some changes here. So it should be market data with filters, right? Here. But before this market data with filters, so what we mean is that before this object is constructed by readObject, we are doing a check here at this point for the stream of bytes. So that's mean that we have to do something before this readObject. So let me create some space here, and we have got this our object input stream. So I will use a set of filter here, set object input filter, and suppose I have got this filter, and let me first of all display whatever is there in this C. So as we discussed that this C should be having serial class, all this like 5 methods which is there. So let's check that. Let's simply print out that what's there in this all this 5 methods. So I'll simply print it out here. So as out system.print, we actually do ensure that I will okay. So I will do C dot plus say C dot serial class, right? Okay. So I will just copy this and put it like here. C dot serial class equals to. So it will give me that what's there stored here in this serial. What is the string value which is returned here? Okay. And similarly, I will do a control. I will just do it for all the other 5 methods. I'm doing control D to duplicate this. So the next would be say array length, and next would be say depth, okay, and references and stream bytes. Okay. Similarly, I will copy this here. References okay, and then we have to return. Now if the C.serial class that has been returned, that is equals to our market data with filters.class, right? If this is, then only we are going to return the status as allowed. Otherwise, it should be rejected. So I will go here and object input filter status.allowed. Okay. Otherwise, we will reject it. Or we can also just mark it as undecided if we want to. So we can also do undecided, or we can also do rejected. So let me change it as a default for undecided, just for the sake that we can also have, because we are just printing it out and just doing on serial class. So we are already going to allow it for this example. The default behavior should be undecided, unless we explicitly want to reject any object from getting deserialized. And the rest everything should be good enough. So because we know that because we here when we are serializing it, we already know that the object that we are serializing is market data with filters. And here in our input filter, object input filter, we are already checking that whether the serialized class is market data with filters.class, and we assume that it should always be allowed. And that's why it should be not failing here and not throwing any exception. And it should simply go here and assert everything as we expect. Now let's run this